Okay, we're going to do a couple example problems before you try some of the problems that is preparing us for our quiz on section 6.1 to 6.3. So this first couple problems are all about finding values of functions and function composition. So in this problem we have two functions. F of x is 3x minus 1 and g of x is x plus 9. So those functions are given to us. So if I look at this, it says f of 2. So f of 2 means I'm going to substitute 2 in for x in the f function. So this is simply 3 times 2 minus 1, which is simply going to be 6 minus 1, which is 5. So we're just putting numbers in. Same thing for g of negative 1. So we're going to put the negative 1 in for x for g. So g of negative 1 is simply going to be negative 1 plus 9, which is 8. Now the next one's a little tricky. It says f of g of negative 1. Well, we know what g of negative 1 is because we just did this in the previous problem. So what this is really talking about, this is talking about f of g of negative 1, which is really 8. So g of negative 1 is 8, so f of 8, now we'll plug that 8 into the f function. So 3 times 8 minus 1, which is going to be 24 minus 1, which is 23. So we're just kind of doing it one step at a time, seeing what I have to plug in and substituting it in. Now the next one's a little trickier. It says, I want to know what is f composed with g. So recall, whatever comes second gets plugged into the first one. So for f composed with g, I'm going to take the g function and I'm going to substitute it into f. So we'll have 3 times x plus 9 minus 1. Now we can simplify that by distributing the 3x plus 27 minus 1. 27 minus 1 is, of course, 26. Now the next one, if you notice, the next one is g composed with f. So the big difference here is always put the second one into the first one. So now we're putting f into g. So when I put f into g, I'm going to put 3x minus 1, which was my old f function, and it just gets added to by 9. So 3x minus 1 plus 9 is simply going to be 3x plus 8. Because negative 1 plus 9, there was nothing to distribute, just kind of looked just like that. Now the last thing we have here is the inverse functions, right? So remember, inverse functions, if you recall, the big thing about inverses is we're switching the x and the y. So we want to find f inverse. So if I'm finding f inverse, obviously I'm going to start with f of x, which is 3x minus 1. So it says switch x and y, but we technically don't have the variable y. But remember, this function value x really means y. It's the output value for a given input. So now I can certainly switch the x and y. So I get x equal 3y minus 1. Now the only problem is now we have to do a little algebra and solve for y. So I'll add 1, x plus 1 equals 3y, and I'll divide both sides by 3. So f inverse is simply going to be x plus 1 over 3. So, very typical kind of process. If you have it in function notation, we'll replace it with the y, we'll switch x and y, and then we'll resolve it out. Now this last one is very similar. It says, if the point 5, negative 6 is on the graph of f of x, what will put you on the point of f inverse? Very simple, because remember, we said if you have a point on the function, then on the inverse, you just switch the x and y.